Alright, so in this problem, I'm going to notice a couple of things. First of all, it says that it's a frictionless surface, so there's no friction, and it says originally at rest. Now, this doesn't actually tell me anything about the motion, but it kind of implies that these two things are going to start accelerating, which means I should probably think about this as an accelerating system with object A, object B, and unless this tension or this chord between the two of them is getting shorter or longer as they move, then the acceleration of A and B are the same. Sorry. So we should just call that A. So the acceleration of both objects is just the same. Okay, let's think about just the system of A, because this wants to find the tension in the chord, and the tension in the chord is actually going to be a force experienced by both A and B. So we need to think about them individually rather than as an entire system, because if we thought of A and B as its own system, then this tension would be an internal force, and the tension to the right would cancel the tension to the left. So let's start by thinking about system A and the three interactions that it has. It would have a weight force down 5 kilograms times the acceleration due to gravity 10 meters per second squared, so that would be 50 newtons. Then there is going to be some force of support up, we'll call it N sub A, and some tension forward. Now that's what we're looking for, so let's call it T. And I don't see too much here, but what I do know is that the sum of the x forces, in this case, is just T, and this is equal to the mass of the system, so mass of system A, times acceleration of system A, which is just the acceleration of the entire system. So I could say A sub A, or rewrite this, that tension is equal to 5 kilograms, which is the mass of system A, times the acceleration. So that's the tension. But I don't have any of those answers here, so hopefully I'm going to find something of an acceleration that gives me an idea of one of these answers. To do that, you could think about A and B as its own system, or you could think about B as its own system. I'm actually going to think about system A and B, so the two of these objects together, because that will give me a certain value that the acceleration of the system will be equal to. So let's see what that looks like. If I do the system A and B, then I'm going to have the weight force of both masses, which is actually 5 kilograms plus 7 kilograms, so 12 kilograms times 10 meters per second squared, which gives me 120 newtons, but I don't really need that. And then some normal force up, I'll just call it N. I could say N, A plus B if I wanted, but it doesn't matter. Now, on this system here of these two objects, if it's frictionless, then the only horizontal force experienced is this 30 Newton force from something that is outside the system. So this 30 Newton force is the only horizontal force. So if I think about the x forces in this system, system A plus B, then what I get is 30 newtons. That's it. And this is equal to the mass of system AB times the acceleration. Now, the acceleration is shared, and the mass of A and B together is 5 kilograms plus 7 kilograms, or 12 kilograms. So 30 newtons times 12 kilograms times the acceleration of the system. So now this becomes fairly easy. All I need to do to find the tension, which I did from finding, just thinking about system A, I need to rearrange this here for A. So I just divide 30 newtons by 12 kilograms, and that gives me the acceleration. Now when I divide 30 newtons by 12 kilograms, I find that the acceleration is equal to 12.5 meters per second squared. So now I have the acceleration, which I can plug in over here to find the tension. 5 kilograms times 2.5 meters per second squared is actually going to give me 12.5 kilogram meters per second squared, or newtons, and 12.5 is answer C.